Alright, so this week is talking about synthetic division or long division when we're dealing with polynomials. So, just as a quick refresher, hopefully you guys are all familiar with this, but let's do a regular long division problem. So, 3 into 4,108, for example. So, hopefully, again, all you remember, you start by dividing 4 by 3. So that will go in there one time. So we put a 1 up here, and then we do 1 times 3. Put that 3 down here. Subtract it. We have 4 minus 3, which is 1. And then we bring down the next digit. So then we figure out how many times 3 will go into 11 without going over. That will go in 3 times. And then again, repeat the process. 3 times 3. And then you bring the 9 down here. Subtract. Obviously that's 2. And then we bring down the next digit. And then 3. How many times 3 goes into 20? Well, that's 6 times. And then 6 times 3, which is 18. Do our subtraction. We get a 2. And then, of course, last step is to bring down our last digit here. Figure out how many times 3 goes into 28. Well, that will go in 9 times without going over. And so we'd have 9 times 3, which is 27. So our answer to this problem will be 1,369 with a remainder of 1. Okay, so that's the basic problem. Now let's look at one that's a little more complex involving polynomials. Okay, so this is problem number 9 from page 305. So the way we're going to do this, focus purely on the x out in front and this first term underneath the division sign. Now obviously I've taken the stuff in the numerator, put it underneath the division sign, taken the stuff in the denominator, and put it on the outside. So again, I'm going to start by looking at just this term and this term, and I'm going to ask myself, okay, how many times does x go into this term? You may find it handy to, off to the side as you're doing these, write these as fractions. So I'm doing negative 9x cubed divided by x. And then cancel what you can. Obviously this x is going to cancel with one of the x's in the numerator, so the answer would be negative 9x squared. Well, that is my first term in my what's going to be my solution. So negative 9x squared. Now I'm going to take this first term here and multiply it by each of these terms out in front. So we pretty much ignore the second half of the term that we're dividing by until we get to this step of the long division. So I'm going to start by doing negative 9x squared times x, which of course is negative 9x cubed. You should, in general, always get the same answer. This multiplication should equal the first term underneath the polynomial. If it doesn't, it's likely you've done something wrong. So the only time you really have to think about it is figuring out, okay, what's negative 9x squared times, again, this, whatever that sign is, if it's plus, then it would be multiplying by positive 2. But since this is negative, we're multiplying this term by negative 2. And again, if you find it helpful, you can kind of do your math off to the side so that you don't inadvertently lose track of anything. So those two negatives will cancel out, give us a positive 18, and of course, that's just going to be times x squared. So, again, that's positive, so plus 18x squared. Now, this is where it gets gnarly for people, because if you remember, from this problem, we're subtracting this line here. So you're essentially subtracting this term from the line above it. And again, I know that that can be like really mind-bending. So you can either think of it as subtraction or just automatically change the signs of what it is that you found when you did your multiplication and then add. Whatever you prefer to do. So again, what should happen is that these first terms should cancel each other out. So the only real math you should have to do is this right here. So if we're looking at 8x squared positive 8x squared minus 18x squared, that will of course give us negative 10x squared. And now I'm going to repeat my process. Oh, but first, can't forget, now I'm going to bring down the next term in my polynomial up here, so negative 7x. So now, again, I'm going to go back out to this term I have out in front, do my division again. So how many times does x go into negative 10x squared? Again, I can do my little doodle off to the side. So this x is going to cancel with one of these x's, so it will be negative 10x. So I would write minus 10x up here. And now I'm going to multiply this negative 10x by each term out in front here. So negative 10x times x, which again, as should happen, you should get the same term that you had started with right there. And then I'm going to do negative 10x times negative 2, which will be positive 20x. But again, you're subtracting all of this. So you really need to change all your signs. So that's going to be plus. That's actually negative, and then add. So once you've changed your signs, you can almost change that to a plus sign. So again, these are going to drop out. So we've got negative 7x and negative 20x, which would give us negative 27x. And then, well, it's not exactly a straight line, but then last step, I'm going to bring down my positive 2 here. And I'm going to do this one more time. How many times does x go into negative 27x? So again, if I write this off to the side, well, clearly these x's are going to cancel, so you're left with just minus 27. So we do our multiplication. Negative 27 times x is negative 27x. And then negative 27 times negative 2, well, that's going to be positive, plus 54. Okay, but again, you're subtracting all of this. So if you factor that subtraction sign through, that's essentially what you're doing here. That will be positive, that will be negative, and that becomes a plus. These cancel. So now you're left with 2 minus 54, which of course is negative 52. And if you try to divide negative 52 by x, well, you can't simplify that any more than that. So you are at the end of your problem at this point. When you're down to just a constant, if you have one, hopefully it's 0, but in this case, we've got negative 52. So that is your remainder. But with division of polynomials, that actually means something a little different. Like normally we would have written this as 1369 with a remainder of 1, right? Well, this problem works a little differently. So our answer is actually going to be this polynomial up here. So our answer will be negative 9x squared minus 10x minus 27. But this remainder just goes over what we were originally dividing by. So x minus 2. So that is the correct way and complete way to write the answer to this problem. Now the book also does this without using, or just using the coefficients, just using the numbers. I actually find that to be more confusing, but if you're able to follow it from the book, you are welcome to do them that way when you submit your homework solutions. It's totally up to you. But I have found in my past experience that teaching that way actually causes more confusion as opposed to clearing it up. So if you would like some further examples on how to do it that way, just send me an email. I'd be happy to put a video out there on the course site. Please let me know if you have questions.